All right, good morning, everybody. So we've made it to day 2, which is not insignificant. All right, how are things going? Any questions on ODPs or logging into the Linux server or any of that good sort of stuff?
You might have gone over this yesterday, but when we do the ODPs, how long does it take to update so we know that? I know like the thing said 10 out of 10, but am I missing a step, or does it update when it turns
I'll
1 out of 10?
probably load things into Canvas on the weekends, so you won't see it for a few days. But if the assessment tool says, 10 out of 10 or 50 out of 50, you're good to go.
Cool, thank you.
Yeah, and the same thing with attendance. I probably won't get around to loading attendance until the weekend. I'll do that once a week.
We have to do our name here every day.
I'll call for attendance first few days. I'm gonna wait a few minutes because people may still be figuring out Zoom and stuff. So in a couple of minutes, I'll go ahead and ask for attendance, and I'll do that near the beginning of class and somewhere near the end of class and maybe in the middle of class. So has everybody been able to get logged in? Is there anybody who has not been able to get logged in? I only had one email last night with a login problem, which turned out to be my mistake. Um, but that would be surprisingly record breaking if everybody was able to log in first day. But I won't
I
come.
got in the day before the first day.
Excellent.
Nice name.
All right, cool. Well, let's go ahead and do an attendance ping. So send me your name dash here. And minor correction. I said you have 3 slip days for the course. You actually have 4 slip days. So I forgot that I added one compared to summer. So you have 4 slip days to work with, not just 3. And that's the same as CSE215, where you also have 4 slip days. And if you send me a here, make sure you put your name in the beginning of it, otherwise it won't get attributed to you. So canvas name dash here. Cool, thank you. All right, so let's talk about working from Linux. Number one, this is a Linux class. Number two, the whole CS sequence is done from Linux. And number three, if you're heading WSU after Clark, most of what you do up there will be in Linux also. So this is really a good opportunity to start, if you're not already there, moving into working in more of a Linux world and a Linux mindset. And there's
UW, do they use Linux as well?
I don't know, but I suspect they do at least somewhat. But I don't know what their particular courses concentrate on. Um, but really, if you're doing any kind of computer development, you're probably not doing it in Windows. You're probably doing it in Linux or OS X, which is Linux. Or if you're doing Android, that's derived from Linux. It's pretty prevalent. And so there's a few different ways that you can find yourself working in Linux. I'll use the terms Linux and Unix kind of interchangeably in this course. But there's a few different ways that you can find yourself in a Linux environment. So the first one is, the Linux server, linux.engrcs.com. And that's, a full-blown Linux environment. The second option is to have a Linux machine in your possession that, boots up into Linux. And that's what I run on my laptop here. That's what you're seeing when we do something like a terminal window. This is a Linux machine. But if you have a Windows machine, you can dual boot. Dual booting can be a pain. Sometimes Windows doesn't play nicely with other things on the hard drive, and it will clobber a Linux distribution and things like that. So your third option, and this is probably the best one for most people if you're running Windows, is to use a VirtualBox setup. And so let's see. I get messages saying that my internet's unstable also from Zoom. If you get disconnected, just go ahead and reconnect back in. And if you end up with a 0 for the day for attendance, just let me know what happened. But if you're here in the beginning and the end, you're probably safe, attendance-wise.
But it is a VirtualBox setup, right?
Sorry, say again?
Isn't it a putty is a VirtualBox setup, right?
No, so let's talk about kind of how the universe is set up. So there's a machine somewhere which we call linux.engrcs.com. And that could be, a physical machine sitting in a rack or under a desk somewhere. It's actually a virtual machine, but we'll just pretend that this is an actual, PC. And it's running Linux. And for example, my laptop it's a laptop. And I can, on my laptop, make a connection to this machine called linux.engrcs.com, and it can come back and send information to me, right? And this happens through a program that I run called SSH. So when I come over here and I say SSH nick at linux.engrcs.com, right now I'm running a program on my laptop, right? This is just, it's like running any other program on my machine, except this program in particular is talking to a remote machine, linux.engrcs.com. And if I say something like show me what directory I'm in, show me my files, these are the files that are sitting over here on this machine. But I'm running a program on my laptop, okay? So maybe I have a Windows laptop, and I also want to connect to linux.engrcs.com. So I can do that, and I do that by running a different program which is called PuTTY. But when you run PuTTY, you're still just running a program on your local machine, right, on your physical laptop or desktop that's sitting in front of you. But what that program is doing is taking your keystrokes and sending it to the server, and taking whatever the server sends and displaying it in your window. And so PuTTY, SSH, Terminus, any of these other programs that you can use to make a connection to a remote machine are still just programs running on, your physical hardware that you have in front of you. And so in 121, we sometimes come away with the idea that PuTTY is a machine, or PuTTY is Linux or something like that. It's really not. PuTTY is just a program that we run to talk to another machine. We can talk to linux.engrcs.com up here. We could talk to ctech.clark.edu. It's a different machine. We could talk to, a time server in Colorado. So it's it's a way to communicate with another system. All right, so virtualization is something different. So with VirtualBox, what you have is you have, let's say, a Windows machine. And you can run a program in here called VirtualBox. And it doesn't go anywhere. It doesn't communicate with linuxengrcs.com or CTEC or anything else. It's a program just running inside your machine, but it looks like an entirely different computer. And this is a way that whether you're running Windows or Linux or OS X or anything else pretty much, you can pretend that you're running on a Linux machine. And so let me show you what that might look like. Let me close this window out. So I'm going to run Oracle VM VirtualBox. And it brings up a window like this. And I have a few different systems installed here. So I'm going to say Start. And it's got a splash screen. It says VirtualBox 6.1. And so there's a video posted on the video area that tells you how to set up VirtualBox and how to tweak it to do some things. Now I happen to be, on a laptop that's running Linux, but if I was on a laptop running Windows, it would still look exactly like this, right? This is just a program. It's just a window. But it's a program that's acting as if this was an entire machine on its own. And what this machine is doing is it's booting up a version of Linux. And so it comes up, there's my splash screen, and I can say let's open a terminal window, and I can say show me the processes that are running, and there's 144 processes running. There's my console program. And I can say let's open up a web browser. I don't have a web browser installed in here. I do. I can open up a web browser and I can do all the things that I would do from a laptop, but it's all virtualized. It's all imaginary, right? It's just sitting inside this program that's running, in this case on Linux, but it could be running on Windows or something else. And so this is a way that you can get, a full-on 100% Linux experience, even if you're running on a Windows machine. So there's a video that tells you how to install VirtualBox, and it basically creates this virtual PC for you, and then on that virtual PC you install Linux. And then when you boot it up, you have this experience, and it's got its own file systems, and it's got its own network interface, and so on and so forth. But it's just a program, so it's not competing with Windows. It's not overwriting Windows. It's not booting you up into something other than Windows. So it's pretty much completely safe as far as not disturbing your Windows environment. But it gives you a way to run VI and GCC and all these other things. And so that's my recommendation to people, because sometimes it's nice not to have to go outside of your machine and make a connection, through the internet to another machine. And this is not a very powerful machine. If we had 60 people doing a lot of work on here, we would see it slow down. And it's just nice to sort of have your own environment sometimes that you can customize and do what you want with. And this is your machine, right? So you can give yourself root access, which we'll talk about more later, but you can turn yourself into an administrator and you can do whatever you want to the system. You can install new packages, you can move things around, and so it's a really kind of comfortable way to play with all this stuff. And if something goes wrong, worst case, you can just rebuild the system from scratch, right? And I've done that a few times, and it's all virtual, so. And you can shut it down.
Does this program run on Mac
This should run on Mac. Yeah, as far as I know, VirtualBox is supported on OS X.
Okay.
Let me do this. And if you don't like it, you can just like close the window. Power off the machine. All right, so that's a good option to explore. And if you go to the videos, so there's an intro to using VirtualBox and Xubuntu. That's going to let you do what I just described. And it also talks about how to do some of the more nuanced aspects of setting up a virtual machine, including being able to like copy and paste between your real laptop and the virtual laptop, and being able to share directories and so on and so forth. So that's a good option to have. All right. So what is Linux? It's an operating system. And let me hop onto the Linux server. So what is an operating system? It's basically a way to work with files and to run programs, right? That's a sort of first order notion. So there are, in my case, 346 things happening on my machine right now, right? Some of those are because I'm running Zoom. Some of them are because I'm running a screen recorder. Some of them are because I'm running cameras to display my document and my main camera and so on. And Linux has been around for a long time. Number of decades, and it was developed at Bell Labs as an in-house operating system, and it was a commercial product for a long time. And then number of decades ago, somebody decided it would be fun to take part of the functionality of Linux and rewrite it in a way that other people could use. And open source software predates that by quite a bit of time, but it was really kind of one of the first really big, large open source endeavors, meaning that it was code that was developed with the goal of letting anybody use it and do whatever they want with it. And so whereas, Unix used to cost, tens of thousands of dollars to be able to get a license to run it, Linux is completely free. And not only is it free, but the source code is freely available. And the source code is available to do with whatever you want. And, very, very wide boundaries. So I keep getting microphone warnings, by the way, so if my audio drops out, let me know. And I will try to keep an eye on it here.
It's not dropping off, it's just like staticky sometimes.
Oh, really? Okay.
I'm not getting audio warnings at all,
Okay. Yeah, I get things popping up saying my microphone is disconnected and reconnected. I don't know why. All right, let me know if audio gets to be a problem. So Linux is an operating system that you have access to all of the source code for, right? And if there's something you don't like about Linux, you can change it. You can take that source code and modify it and rebuild a new version of Linux. And so you hear about Linux distros, and there's all kinds of different flavors of Linux. So there's Ubuntu, and there's Cali, and there's mint, and all these other flavors. For what we're going to do, it really doesn't make a lot of difference. We're going to mostly work from the command line. Now Linux, is similar to Windows and OS X in the sense that, we have a graphical environment. I can, run things like a browser and so on and so forth. I can point and click. I can get to a menu of items. I can say, find an application, and so on and so forth. But most of what we're going to do in this course and in 222 is going to be done from right here, from the command line. And command lines, certainly predate graphical interfaces, GUIs, by quite a number of years. And there's very little that you cannot do from the command line other than, playing games and web browsing and things that are sort of inherently visual, GUI based. But as far as core functionality, manipulating files, compiling programs, debugging, things like that, you can do most of what you need to do from the command line. And it's generally going to be more efficient from the command line. Hey, thank you.
Yeah, good.
And someone said, hello, Mrs. Macias.
Oh, hello.
So we're going to concentrate on the command line, and as we go through the course and start developing code and so on and so forth, I'm going to ask you to stick to the command line. Now there are lots of graphical tools we can use to do code development. We can use code blocks, we can use Visual Studio, and so on and so forth. We want to stay away from those, okay? Because we're trying to learn fundamentals. We're trying to understand how this stuff actually works. And if we use something like Visual Studio, right, what happens? You say, okay, I want to make a new project, and boom, 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 you've got 100 lines of code written for you already. And what does that code mean? What does it do? How do we make our project something slightly different from that? Right, we're going to learn that by avoiding those automated tools. All right, so another aspect of Linux is customizing. So when we're sitting at a command line, right, there's a set of commands that we can use. For example, if I want to see the files in my current directory, I can say ls, and it'll show me the files in my directory. If I want to know what directory I am, I can say show me my current directory. If I want to change directories, I can say let's change into CSE224, and now I can list files in here, and so on. But you can also create your own commands, right? You can set up aliases where you can type one thing and it will mean something else. And so, for example, I have a whole bunch of aliases set up, right? If I want to record, I can just say record instead of saying Kazam. If I want to, I don't know what that does. Oh, I know what that does. So if I want to run a package called a Xilinx package, right? Normally I would have to type in all of this stuff. Well, I can just type Xilinx, and it means Xilinx setup, and it means all of this stuff. So you can set up aliases. You can obviously customize your display. So I like a black background with green text. That's just me. That's what I grew up with. But I can customize this terminal window. I can change the font. I can change the size by just control scroll wheeling. You can change color schemes and so on and so forth. So as you go through the course, sorry, go ahead.
Where are these located in your file?
So I just use the command alias, and that'll show me all of my aliases. And I'll show you how to set those up in a few minutes.
Awesome.
So as you go through the course and you're working in Linux, keep in mind that you're not stuck with anything, right? If there's a command you really hate, you can change it, right? Maybe I don't like the ls command because, I can't remember what ls means, right? Maybe I want it to be some other command like directory or dir, right? I can set up a command called dir that means ls. And there's lots of ways you can customize. And every command that you run in Linux, like ls for example, that's just a C program. It's a program somebody wrote long time ago in C, and when you run this program, it shows you the files in your current directory. And if you say ls-l, it shows you the files with some additional information, like their size and the date that they were created, and so on and so forth. And you can write your own C programs to do other things, and if there's commands that you find useful, you can write code to create those commands. So for example, when I start class, I do a cam setup command. Now I'd already done that, but cam setup creates, this window that lets me do my documents, and it creates this window up here that shows you the view of me. When I say countdown, it creates this little countdown bar that shows me how much time we have left in class. When I say TS, it runs this timestamp program that lets me type in messages. Those messages will get displayed, and it'll record the timestamp of that, so that when I upload the video, you can see, a link that you can click on to get to that part of the video. Right? These are just, simple programs that were written to help me do the things that I need to do when I'm teaching. And you can do this in your Linux environment. So if you do a lot of certain types of development, or if you're doing document writing, or you're moving around between classes, right, you can customize and tailor the environment. So I just want you to be aware that those things are doable, and then as we move forward, we can talk about how to do them. So ls shows you a list of files in your current directory. There's a concept called hidden files. And hidden files are just what they sound like. They're files that you don't normally see. There's nothing special about a hidden file. It's just that the ls command for seeing files in a directory by default does not show you hidden files. If I say ls-a, it'll show me my hidden files as well as my regular ones. And now I can see all these files that start with a dot. These are files that are normally not being shown to me. Let's see, question. Do you have a file or document of the Linux commands we should know for this course? I do not, but I do have a quick start guide that's posted on Canvas, and it has some commands. So just a few basics to get you going. So VI, how to compile, how to execute a program, capture the output, look at the contents of a program, the ls command, copying, making subdirectories, moving around directories, and so on. And the Linux textbook for the course certainly shows you, all the commands you would ever want and a whole lot more. But this is an edict that I'll come back to a lot, right? Linux is this big thing. We're going to talk about, this tiny little piece of it. And you're going to come out of the course hopefully knowing that tiny little piece, but probably knowing some other pieces as well. And what you're going to end up with is your own personal toolkit, your own set of tools, and your own ways of doing things that are, whatever makes the most sense for you. Now for a course, you're getting tested and stuff, you got to learn the stuff that I teach you also. But on a bigger scale, right, what you want to do is learn the things that work for you, and then have that be, your toolkit. So hidden files, right? They start with a period. They're not shown when you do just a plain old ls. But they're files that are useful to have around usually, but we don't want to look at them every time we say, show me the files in my directory. And in my home directory, there's a file called .bashrc. And we'll talk about bash later. But bashrc is basically a way to do certain things whenever you first log into the system. And so, for example, inside my bashrc, I have a command which says, let's alias Xilinx setup to mean all of this stuff. Okay, that's why I can say Xilinx setup and it executes these commands. I have Linux, Linux, set up as a shortcut for nick at linux.engrcs.com. And I make typos sometimes. I make the uppercase L instead of the lowercase, so I also set up uppercase Linux to be an abbreviation for nick at linux.engrcs.com. So if I say SSH $Linux, the $ says see what this is equal to, and just SSH to that. So that takes me into my Linux server.
I've messed with bash RC so much.
You would?
I've messed with bash.
Oh yeah,
RC
totally.
So much. Super useful.
So bash RC is a place that you can set up customizations for you. I also set up my prompt to look like this. It's a number inside brackets. And the reason I do that, if you do the command history, you'll see a history of, in my case, the last 2,000 commands. And I can go back and re-execute a command by just saying exclamation mark and the number. So if I wanted to redo, this command here, I could say exclamation mark 1998, and it repeats that command. And it's just something I started doing, about 40 years ago, and I just got in the habit of it. But you notice when I'm on the Linux server, I have curly brackets instead of square brackets, because sometimes I think I'm on one machine and I'm actually on a different one, and end up doing something I don't want to do. So anyway, lots of opportunity for customizing things, and we'll talk about those in a more controlled way later on. I'm just kind of still doing a really broad brush stroke over the overarching themes here. Let's look briefly at directories. So when you first log in, I'll go ahead and do this on the server. When you first log in, you're in a directory. It's going to be /home/ whatever your username is. And normally it might have, one or two directories in it, but it's mostly empty. But you can create subdirectories. Okay, these are called folders on Windows. But these are other directories. Directories are just folders where you can store information. So if I do an ls-l, I have one file in here which is called mbox. That's where my mail messages get stored locally. But all these other things are directories. So for example, I can say, let's go into this 24 new directory. And I have two files in here. That's the ODP that I used in my afternoon class yesterday. And I could make a new directory underneath this, and so now I have two files and a directory. And if I go into that newer directory, there's no files in there yet, right? So it's a hierarchy of files and directories that create our file system. And so this is something you can use to organize your work. So for example, here's my 224 setup. Maybe I want to work on homework 01. I could make a directory called homework 001. And if I want to work on programming assignment 1, I could make a directory called programming assignment 1. Right? The alternative, the other end point on this spectrum, is you do everything in one directory, and that's a nightmare. You end up with 500 files. They all sound similar to each other. You end up accidentally clobbering one piece of code from a few weeks ago because you're writing something else with a similar name, and so on. So you want to organize your work, right? And again, you organize it in a way that makes sense to you, and it's totally your choice. All right. Let's see. So, a few quick keyboard things to know in Unix. So, if you're running a program and it's stuck in a loop, ctrl-c is the way to get out of it. So, for example, Alright, I got myself in an infinite loop here, right? And whatever I type, I'm stuck in this loop. Okay, how do you get out of it? Control-C. So hold down the control button, press C. That should get you out of most things. There are a few exceptions, but generally that will get you out. What you don't want to do is Control-Z. Control-Z will also get you back to your terminal sometimes, but it doesn't actually kill your program. Actually, it doesn't get me out of here at all. Control-Z stops your program, but it doesn't kill it. It keeps it around, and it leaves it in a suspended state. And we'll look at when we want to use Control-Z later when we talk about processes. But for now, the main go-to if you're stuck in a loop, Control-C. If you want to exit from anything, you can sometimes use exit, but you can always use Control-D. For example, if I type the word cat, I'm stuck in a program now, right? Well, Control-C would get me out, but so would Control-D. So hold on, Control, hit D, and that says, hey, get me out of this program. But I could also Control-C. And when you want to log out of the Linux server, for example, Control-D will log you out. And that's whether you went in with SSH or PuTTY or anything else. Let's see, other things to know. So you can use your arrow keys. Most people have already discovered this. You can use your arrow keys to get to previous commands. So I can up arrow and get to previous commands. I can down arrow and come back. You can move around left, right if you want to make edits. You can control left arrow to move around entire words at a time.
You can hit tab when you're typing something like directory. You know what the name is, but it's like a super long word. You can hit tab and then enter.
So tab is going to be your best friend. So tab is for what we call file name completion. So let's say I want to edit my README file, right? I could type vi readme and hop into my file. But if I type vi and I just type the letter R and then I hit a tab, it will try to complete my file name. And since I only had one file that started with an R, it filled in the rest of that file name for me. So for example, if I want to go into CSE224 work area, I could say cd space and I can just type a C and hit a tab and it filled out the rest of that for me. And this is really useful when you're compiling files with really long names or you're moving to really long paths and so on and so forth.
Does it choose the most recent word, or does it just the most alphabetical?
So if I say CD and I type a 2 and I hit a tab, it won't complete because there's ambiguity. If I hit tab again, it will show me all my possibilities. But it won't complete anything if there's ambiguity in what you've typed so far. So if I know I want to go into 224, I'll type a second 2 and hit a tab. Well, now it was able to complete 224, but at that point it's ambiguous. If I hit a tab again, it'll show me my possibilities. Now if I just type a G and hit a tab, it'll go ahead and fill in the rest of that. And these are really, really fun to play with. It's like the most boring video game you would want to Twitch, but it's really fun once you get used to this. You don't even think about it. And it's kind of like, you know, a magic auto-completing genie working for you. And it becomes second nature. You just find yourself using tab all the time. And so much of what we do in Linux is about, you know, the little things, right? To type in CSE224 work area might take me 4 seconds. Is it really a big deal to save 4 seconds on typing that? No, not by itself. But if I'm going to be sitting in front of my computer for 10 hours working on, you know, getting this program to work, if I can avoid spending any brain cycles typing in CSE224 work area, right, that's going to end up making me more efficient It's going to keep me in the zone, right? And it's just going to improve things all across the board. Yeah, you got a question? Go for it.
So you know how if you like repeatedly if you like put in like a bunch of commands and you're like and you feel like your like command line screen is all cluttered and stuff, how do you is there a command for clearing that without your entries?
For clearing the screen?
Yeah.
Yeah, so you can just say clear, and that
Oh my gosh.
gets
Yes.
you back to a
Okay.
fresh start. But all of your commands are still there, all of your history is still there, and so on. And you can still scroll back and see a little bit of your history.
Thank you so much, Nick. I couldn't remember what that was.
Okay, yeah, you're welcome. And that may vary from environment to environment, but most setups that you have for connecting to a system or running Linux, clear is going to work. And this is a good time to introduce the manual pages. So Linux has always had online documentation available, and it's inside the Linux system. It's not going out to the web or something like that. There's documentation inside the operating system itself. So for example, if I say man clear, that will show me what's called the manual page for the clear instruction. And this is a really short manual page, right? It says the name is clear, clears the terminal screen, synopsis clear, and then there's a description. Clears your screen, other things that I might want to see, and you know, it's less than one page. If I do man on GCC, that's a little bit longer, right? This is a manual page with a lot of information in it. But this stuff is always available to you. And the manual page is one of those places where if you want to get out of it, if you're looking at it and you're done, Control-C will not take you out, but it says right down here, type a Q to quit. So if you just hit the letter Q, it quits. You can also do keyword searches, right? If you don't know what the name of the command is you're looking for, you can't look it up. But you can say, show me things with the keyword clear in it, and this will often give you a lot more information than you want, but this will show you commands that involve the word clear somewhere in the synopsis. And so here we can see, oh, there's the clear command. Or if you can't remember how to compile, you can say man-keyword compile, and anything that describes anything to do with compiling will pop up here. And so there's a C++ compiler and a C compiler, there's the GNU compiler, and so on and so forth. Chat question, how do you go back a directory? Oh, okay, good. Yeah, so CD will change you into your home directory. CD followed by a directory name will change you down to that directory, and if you say CD ... that'll move you up a directory. And you can go all the way up to /, and that's the top level.
And if you type OS, it'll also list out the different things that you have in your current directory.
Which command is that?
LS.
Oh, LS.
Yeah.
Right. And so right here, I'm in the top level directory, right? This is called the root directory, and I don't have permission to write in this directory, right? Because I don't own this directory. My directory starts at /home/Nick. So if I try to write something in here, it's going to give me an error and say I can't do that. But I can look at things in here, and I can go into the home directory, and if I did an ls, I would see the name of every Linux login in here, right? But I wouldn't be able to write there. I have to go down to my home directory, and then I can start writing files in here.
If you're in the topmost directory or any directory you're in, this is a good question, and you type CD, does that automatically put you back to your home directory?
So CD with no arguments always takes you home.
Okay.
And also, if you do cd and a tilde and a username, it will take you to that user's directory. So if I go into tilde test, that would try to take me to /home/test, except I don't have permission to go to that because that's a different user. That's my test user. Or Goblin King or whatever. Alright, let's talk about backups. So how many people have ever lost a bunch of files from their computer because a hard drive crashed or something got accidentally deleted? Or you thought you were somewhere and you removed a bunch of files and they were the wrong ones?
I lost some source files the other day.
Yeah.
It's probably happened to me at least once. I don't remember them.
I think it happened to me about 4 days ago was the last time. It's kind of inevitable. The more you work, we got some lucky people out there. The more time you spend in a computer environment, the more likely you're going to eventually lose some stuff, especially when you're working on a command line, because it's so easy to get into trouble. So rm -rf star, that'll remove every file in your entire directory tree. If you do that from your home directory, it wipes out everything. If you happen to be root and you do this from /, this will delete every file on the system. I've done it. It's not good. And you can make your machine to where it's unbootable, because to boot a system, right, is really this is part of the boot process. And if you remove the wrong file, you might brick your system. So it's really easy to get into trouble, and it's really important to have backups, right? To make copies of your work in some way that if something happens, you can get back to where you were reasonably, without too much loss of work. Hard drives fail. Things go out to lunch, people break in and steal things, stuff like that. So you definitely want to think about backups. And there's a number of different ways we can do this. A quick and easy way when you're working, on a project is to just make copies of your file. So sometimes I'll just make a directory called backup, and every now and then I'll just copy my files into that backup area. That's a quick and dirty solution. Yeah, that's sad. You can use, flash drive if you like external storage. External hard drives are pretty affordable now, and you can back up on there also. But we're going to also use something called Git. And Git is a whole bunch of things, but at one way of looking at it, it's really just a really pretty painless, cheap, it's free backup system that you can use as you're working on a project to make backups. And you can make these backups offline. You can leave them in the cloud. And GitLab, which is what we're going to use for this course, gives you essentially unlimited storage. It comes in 10 gigabyte chunks, but as long as your one particular project you're working on is not bigger than 10 gig, you have basically unlimited storage. And it's in the cloud, it's backed up, it's secure, it's archived with redundancy and so on and so forth. It's fantastic. And so I've been using GitLab for years for all of my more serious work that, if there's a fire in the apartment and everything gets destroyed and I still don't, I want to be able to get to this work, I throw it on GitLab. And we're going to use GitLab here not just for backups, but also as a way to submit your assignments. All right, so we're going to dig into the details of GitLab tomorrow, but you can start reading about it in that how-to on Canvas, and you can look at homework 2, which relates to GitLab, and you can try to run through that yourself if you like. But tomorrow we'll go through Git kind of from the beginning to the end. There's also some videos posted on the class playlist that talk you through using GitLab. So there's multiple pathways to that if you want to try it. GitLab and GitHub. GitHub is older. It predates GitLab by a number of years, but GitHub got bought by Microsoft a few years ago. And when that was announced, a bunch of people jumped ship, including me. And GitHub used to not allow you to have private repositories unless you paid. I think they've changed that. But at the time, your repositories were automatically available for everybody to see, and that wasn't going to work for a classroom setting. So I switched to GitLab. But, you know, they're both solid. But we got to use GitLab for this one, because that's what I'll be pulling from. Alright, so go ahead and send me a final attendance ping. Let me know that you're here, and we will call that good for today. And tomorrow we'll start digging into Git.